first big application of calculus and derivative calculus is to find the equation of a tangent at a point on any curve. Now, we're going to do a lot more than that, but this is our first major application there. So remember what a tangent was. We talked about a tangent when we were looking at the first principles, that the tangent was a line that touched a curve at one point only. So there's our tangent to our curve. So we know that at that point there, the gradient of the curve and the gradient of the tangent is exactly the same. So that's an important point to make, is that remember, if we zoomed right in on that, then we get the situation where that line, that curve will look pretty much flat, and they'll touch only at one point. And remember how tiny our point is. So that's where we get a tangent to the curve there, and we could draw a tangent. The tangents are infinitesimal there. Infinitesimal. There's an infinite number of tangents we could get there, because the gradient goes on forever in both directions. So what we're looking at to do is to find the equation of a tangent. Now remember, a tangent's a straight line. So equation of a tangent, which is a straight line, we need two things. We need the gradient and a point. Well, we're usually going to be given that point. The idea is to get the gradient. And how do we get the gradient? We use calculus. That's what it's all about. So what are we going to do there? So we know that the key here is that any particular point, we get a gradient of the curve and the gradient of the tangent are the same. So that's what it allows us to do. So we want to find the equation of the tangent to the curve there at the point where x is equal to 1. So what do we need? We've got our x value, we need our y value. Well, substitute y into there, x into there, and we get our y value. So 2 lots of 1 squared plus 1 minus 4. So we just did a substitution of 1. Gives us minus 1. So there's our point. That's the point on the curve that we want to find the gradient, find the tangent at. Now we also need the gradient. So how do we get that? Well, we get our gradient function. That's what the first derivative is going to do for us. We get our gradient function. So we derive 2x squared becomes 4x. Derive x becomes 1. Derive minus 4 becomes 0. So that's why we get that function there. And when x is equal to 1, we get our gradient of the curve. So 4 times 1 plus 1 gives us 5. So there's our gradient. There's our point. We put it into our equation of the tangent, and we use the formula y minus y1 equals m outside of x minus x1. So that's where we get our equation of our tangent. So we do that substitution. We get y plus 1, expand our bracket 5x minus 5, and then we can clean it up by putting all the terms on one side together. 5x minus y minus 6 equals 0 in the general form. So there's what we're trying to do. We're trying to find the equation of a line, and to do that we need a gradient and we need a point. And we're getting our gradient this time using calculus. So this time we've got a curve 3x squared minus 5x plus 2. We need to get two things. We need to get our y coordinate because we've got our x value, and we need to find our equation so we can get our point. We need to find our gradient so we can get our equation, because we need the gradient and the point. So we get our first derivative, because that's going to give us our gradient function. First derivative, gradient function. So at x is equal to 2, we get the gradient there. We sub 2 into the gradient function. 6 times 2 minus 5 gives us a gradient of 7. And we get our y value by substituting it back into the function here. So 3 lots of 2 squared minus 5 lots of 2 plus 2. Do the calculation, gives us 4. So there's our gradient, and our point is 2, 4. We substitute into y minus y1 equals the m outside of x minus x1. So we're using that point, we're using that gradient right there, and that's where we're going to expand out, collect our terms, and get our gradient, the equation of our function there. So we've got to be really careful. We've got to just be careful to make sure we get our gradient correctly. We're using the correct point. So, but they're the two things we need to get, and our gradient comes from using the derivative function. So this time we're going to have our function 3x squared minus 5x plus 2, our point where x is equal to minus 1. So again, we get our gradient function. 3x squared derives to 6x. Minus 5x derives to 5. And the 2 derives to 0. So at x is equal to minus 1, our gradient there would be 6 times minus 1 minus 5 gives us minus 11. And we put minus 1 into our function, so 3 lots of minus 1 all squared, minus 5 lots of minus 1 plus 2 gives us 10. So again, just be careful with all your negatives and positives that are going on in both equations to get our point and our gradient. We substitute it into the equation, the point gradient form of a line, and expand out, collect our terms together to get our equation of our tangent. So there's what we've got to do each time. To find the equation of tangent, we need to get the gradient because we're getting an equation of a line, get our gradient, and we get our gradient from the first derivative because the tangent at the point x equals minus 1 has the same gradient as the curve does at that point. So we get our point, we get our gradient, and we're able to find the equation of our tangent. So we need to do that every time we want to find the equation of the tangent.